Let's talk about some basic division of monomial complex numbers. And by monomial, I mean one term on the top, one term on the bottom, one term on the top, one term on the bottom, one term on the top, one term on the bottom. When you divide complex numbers, you have to clear the imaginary number from the denominator. You can't have an I in the denominator. So in order to do that, we have to find something to multiply this fraction by that's going to clear that I out. Well, you can multiply I by anything and it's not going to get rid of it. The only thing you can multiply I by that will change the value is another I. Well, if we multiply this by just an I in the denominator, you're going to change the entire value of this fraction, and we don't want to do that. You can multiply anything you want by 1 or some variation of 1 without changing the value of the original expression. So we're going to multiply this fraction by I divided by I. I'm going to change that to multiplication symbol. And because I divided by I is still a 1, anything divided by itself is 1. But in doing that, it allows us to get rid of this in the bottom. So in your numerator, 3 times I is 3I. And in the denominator, I times I is I squared. Well, remember, I squared is the square root of -1 times the square root of -1. The top stays 3I. Let's finish this off. We have 3I divided by the square root of -1 times the square root of -1 is a -1. 3I divided by a -1 is a -3I. And there's your final answer. Let's look at the second one. -2 divided by 4I. Well, change that to multiplication, and we're going to multiply the same thing. We're going to multiply by I divided by I. That's going to give us -2I on the top, and that's going to give us 4I squared down on the bottom. Again, 4I squared, that's the same thing as saying 4 times a -1. So we have a -4 on the bottom, -2I on the top. So our final answer would be 1/2 times I. So 1I divided by 2, which can be written as just a plain I divided by 2. And there's your final answer. The last one, we have -8 divided by 3I. Let's go ahead and multiply by I divided by I. We have -8I divided by 3I squared. Well, 3I squared is the same thing as 3 times -1. So that's a -3 in the bottom and -8I on the top. Negative divided by a negative is a positive. So we have 8/3, 8I divided by 3. And that's it. Make sure you have those 3 written down because I'm going to change it up just a little bit. Now what happens if you have something like 4 plus 2I divided by 3 plus I? Multiplying by I divided by I is going to give us 4I minus 2, because this would be 2I squared, which is going to be a -2, divided by 3I plus I squared. So it would give us 4I minus 2 divided by 3I minus 1. we still have an I in the denominator, and you can't simplify binomials like that. So this doesn't work. Multiplying by I divided by I does not work for this. In a case like this, we multiply by what is called the complex conjugate. A conjugate is just, it's the same number, but with the opposite sign in the middle. So the complex conjugate of 3 plus I would be 3 minus I. The complex conjugate of 4 plus 2I would be 4 minus 2I. So what we're going to do is you're going to multiply this by the complex conjugate of the denominator. So we're going to multiply this whole fraction by 3 minus I divided by 3 minus I. Again, it's still 1. 3 minus I divided by 3 minus I is 1. Anything divided by itself is 1. So now we have these two binomials that we need to multiply. So we have, let's do this in different colors here. We have 4 times 3, which is 12. We have 4 times a negative I, which is negative 4I. We have 2I times 3, which is a positive 6I. And we have 2I times a negative I, which is a negative 2I squared, divided by 3 times 3, which is 9. 3 times a negative I is a negative 3I. I times 3, which is a positive 3I. And the last one of I times a negative I, which is a negative I squared. Colors didn't change that well. Now we can simplify. Well, negative 2I squared is like negative 2 times a negative 1. So this is a positive 2. And a negative I squared, the opposite of I squared, really, is, you know that I squared is a negative 1. The opposite of that is a positive 1. So let's go ahead and simplify these numbers. We have 12 plus 2 is 14. We have a negative 4I and a positive 6I is a positive 2I. And then we have down here, we have a 9 and a positive 1 is 10. And a negative 3I and a positive 3I cancel out. That's why we multiply by that complex conjugate, because that's how we get the I out of the denominator. These are not supposed to share the denominator. Remember, in a complex number, there has to be a real part and an imaginary part. So this is 14 tenths plus 2I divided by 10. And you can certainly simplify a little bit further. So this would be 7/5 plus I divided by 5, because 2 tenths is 1/5. And there's your final answer. Go ahead and make sure you have this written down. I'm getting ready to move to another page. All right, let's try 6 minus 4i divided by 8 plus 3i. First thing we need to do is multiply by a complex conjugate. So that would be 8 minus 3i. 8 minus 3i. I'm going to go ahead and give you a second to pause this here. And before you simplify anything, just write it out. So you should have 4 terms on the top and 4 terms on the bottom. Let's see what you end up with. Hopefully on the top, you ended up with 48 minus 18i minus 32i plus 12i squared. And on the bottom, 64 minus 24i plus 24i minus 9i squared. So let's go ahead and simplify this. Remember, so 12i squared would be the same thing as a negative 12, and negative 9i squared would be the same thing as a positive 9. Go ahead and pause it here, and then make sure you have this written down, and then see if you can work it out and come up with your final answer. When you combine the like terms, 48 minus 12 is 36. Negative 18i minus 32i, that should be a negative 50. Minus 50i divided by 73. So this should be a negative 50i. And then 64 plus 9 is 73. So your final answer, rewrite that. 36 divided by 73 minus 50i divided by 73. You have your real part and you have your imaginary part. You may see it as 36 divided by 73 minus 50 73rds I. Okay, the last type of problem I want to show you is something like if I have the square root of negative 36 divided by the square root of negative 4. Well, you can't do anything with negative square roots in there. So you know that the square root of negative 36 is the square root of negative 1 times the square root of 36 divided by the square root of negative 1 times the square root of 4. And we know that square root of negative 1 is I. Square root of 36 is 6. So we have 6i divided by 2i. In this case, you have an I on the top, an I on the bottom, so that can be simplified to just plain 3. And let's take a look. 6i divided by 2i. We multiply that by I divided by I. We get 6i squared divided by 2i squared, which would give us a negative 6 divided by a negative 2, which is a positive 3. Let's go ahead and do another one. About the square root of negative 100 divided by the square root of negative 9. This would be 10i divided by 3i, which is just 10 thirds. And that's it.